All right, about a month ago, we were looking at where the James Webb Space Telescope was at. And now that it's March, I thought we'd take a look at the news and kind of see what's happening with JWST. So, if you've been looking at some of the news, in space news at least, you will have seen some new images. Last time we looked, we were seeing pictures kind of like this one here, where there were multiple pictures from each of JWST's mirrors, right? All of its mirrors. If you remember, the Webb telescopes, which is this amazing new space telescope that's like way bigger than the Hubble and going to take way cooler pictures, is it looks kind of like this. It has this huge sun shield. It's far away from the Earth and the Moon, so that shield is blocking out not only sunlight but radiation from the Earth and the Moon. And then it has this segmented mirror, this huge gold-plated segmented mirror with all these hexagonal pieces, which are currently being aligned. That light reflects off this secondary mirror, which is supported by these booms, and then down into the hole in the middle here where the instruments are on the back end of the telescope. So the new cool picture this week, which is really cool, this is in a sense like the first focused image, right? Because before, the telescope wasn't really aligned. All these mirrors were being aligned on top of each other. And now we see first picture of a star where all of these mirrors are aligned to each other. You get this crazy diffraction pattern, which is what you see when you have a really bright star and you have a really pure sky, because there is no sky because you're in space. And you can even see all these galaxies in the background, which is really cool. Now, one of the other things I notice here is at the very bottom, maybe you can see that this kind of noise almost, if it were right there. You see how there's all that speckle around that star? And as we look at what they're doing right now with the space telescope, you'll see one of the things they're kind of doing is removing that speckle. But nonetheless, you can see it's already focused in really cool ways. And let's take a look at what they are currently doing. So this is the other image that's come out. So they have a way of capturing a picture, they call it a selfie, of the mirrors, right? And you can actually see the shadow of the boom. So this is illuminated by a bright star. And it's showing just how, it's an actual picture of the mirrors in space, which is really, really cool. It's almost like a shadow of the pictures. So the website is really awesome. It's jwst.nasa.gov, and it allows you to kind of track along with what's happening inside the Space Telescope. And let's just see where it's at right now here in mid-March. It's saying the Webb is cooling and aligning the mirrors, but we can dig down into the details there if we click on track. And you'll see, I've showed this to you in the last video, but it shows everything from launch all the way to where we currently are. And there's several things that are happening right now. It'll see the status right here. You could say the near cam, which is one of the primary instruments, cameras, is cooled, very, very cold, right? Negative 244 degrees Kelvin, because this is going to be detecting infrared light. So the camera itself has to be so cold that it's not glowing in the infrared. What else is going on? We can kind of click through here. So the mirror alignment is still ongoing, and it has all these stages to mirror alignment. We saw these earlier stages, which are already complete, where each mirror is being lined up. In a sense, you're kind of tilting each one to say, which one is this? You think about the complexity of this, almost like trying to tune a piano, right? It's like you have all of these noises, right? All these dots all over your picture. But to line up each one, you have to, in a sense, figure out, well, which dial controls which one of those dots. And once you get them all to line on top of each other, there's even additional levels of precision, right? You have to have like A and B precisely lined up with each other. But then C and B have to be precisely lined up with each other. And D and A have to all be precisely. So each one of these at a level of precision that is truly mind-boggling. And that's what we're seeing are the current stages. So stage 2 is complete. Stage 3, this is where we're starting to get closer to the image we just saw this week, right? You see how those mirrored images are being brought to the center. And now it's saying stage 4 is complete. Now we're talking about coarse phasing. This gets actually into the optics of actual wavelengths of light. So that these mirrors, and this is super cool, I'll show you just a video here, that these mirrors get aligned so precisely that they are just mere wavelengths of light, nanometers off from one another. And this is getting at what I'm talking about, like A and B. So these two mirrors, for example, this is what they call coarse phasing. They have to be adjusted so precisely that that they're off from one another by only a few wavelengths of light. And that's why you see this interference pattern. If you've ever learned about that in physics or optics along the way, you get interference when these light waves are very nearly aligned to each other. And the closer they get, right, then the more and more focused this image becomes. We want all of these mirrors to not just like overlap pictures with each other, right? We're not just saying like, I want to take this picture and overlap it with this one. In order for it to actually work as a single telescope, you need those individual mirrors to sort of act as one. And that means you need them to be aligned so that the light is bouncing off of it as though they are the same mirror. And that means getting this kind of phasing they're talking about, that the actual light wave, right, is bouncing back in phase. That's what phase means, is that they're in phase with each other, which is insane that that can be done, especially at optical wavelengths, right, where we're talking about hundreds of nanometers. So that's this coarse phasing, right, which it looks like from those images that it's doing that like one mirror with a neighboring mirror. And then that's already complete. Where we're at now, this is complete. Fine phasing, which it looks to me like is getting many of those mirrors lined up with each other and in phase with each other. And you start to see that speckle I was showing you in that image. You see how this speckle is the optical term for it. You can see that star zoomed in, and it actually kind of reminds me of the image we saw here, right? Of that speckle in this star down below. The bright star is undoubtedly doing it. It's just so saturated we can't see it. That kind of speckle. So that gets minimized by these phasing activities. Let's just see what this video shows us here as well. So again, this is a simulation like with a test bed, right? They were testing all this stuff in the lab first. So when you zoom in on that star picture, it's actually quite blurry because these things are not in phase with each other. And so then you can see, I'm assuming these images on the right are the actual images from the Space Telescope. So as these things get phased in with each other, the image becomes much, much sharper, right? Again, we're all striving for as much detail as possible. This is a unique challenge because we have this segmented mirror, right? Which has really never been done before in space. All right, let's see. Now that's been completed as well. So let's see what is ongoing. Okay, right here. Telescope alignment over all instrument fields of view. So after the fine phasing, the telescope will be well aligned at one place in the field of view, right? So it covers a part of the sky. They're going to focus it in one spot, but now they need to extend that alignment to the rest of the instruments. In this phase of the commissioning process, we make measurements at multiple locations or field points across each of the science instruments. So that reminds me how like on a camera, like on your cell phone camera, you might, if you were taking a picture of someone, you'd like tap and then you get a phone call, of course, but you would like tap and then that focuses on that. See that little box? But if I tap here, it'll focus on my face. If I tap over here, it'll focus on that in the background. And in a sense, that's what they're doing, is they're exploring the field of view, and they are focusing in all those different areas. That's amazing. So that's going to be going on for a while. And then they're at the last stage, iterate alignment for final correction. So after applying the field of view correction, addressing the removal of any small residual positioning errors. So they'll basically repeat that fine phase process. Wow. So we're getting really, really close. And then what comes after this? Just looking ahead, maybe a month or so, what are the sorts of things we're going to be looking at? I believe, when we're getting close to the end here, it comes down to like commissioning the actual instruments, right? So there are many different kinds of cameras on board the Webb telescope. And so they'll be presumably testing those, and we'll be seeing more and more fantastic pictures as the months progress. All right, very exciting stuff. This is going to be delivering amazing pictures for years to come. And in the same way that people will talk about Hubble, like it's been my whole life, Hubble has been like the space telescope. James Webb is going to be the space telescope. So it's really cool to follow along as it's coming on board. All right, we will catch you later.